In this video, we're going to be covering linear approximation and polar functions using average rate of change. So, everything about this topic comes from the idea that r equals f of theta is exactly like your rectangular function y is equal to f of x. So what is a polar function? Our polar function, we have theta, which is our input, our angle in radians, and we have our output, which is our distance from the pole. Now, in rectangular, we had our x input and our y as our output. What is average rate of change? It's slope in rectangular, and it's also going to be similar in polar. So in rectangular, we have seen that we have f of x of 2 minus x of 1 divided by x2 minus x1. So using our polar equivalences, we have so this tells you how fast r changes as theta changes, while in rectangular we have how fast y changes as x changes. Now let's talk about relative max and relative min. This is the same thing as local, relative and local. We're not going to use derivatives here. We're going to use the sign of the average rate of change. So when you have a local max, this is when the average rate of change goes from positive to negative. So what this means is that r was increasing, and then we have r starts decreasing. Now, on the other hand, when we have a local min, this again is when the average rate of change changes, and this is when it goes from negative to positive. So originally r was decreasing, but then r starts to increase. So what does this mean geometrically? So if you have a positive r and you have an increasing r, that means you're moving away from the pole. However, if you have a decreasing r and it's positive, that means you're moving toward the pole. And you can think of this as the pole is just, again, 0, 0. So if it's increasing r, that means it's going farther from 0. But when it's a decreasing r, it's getting closer to 0. So remember, if you have the max r, that's going to be equal to the farthest distance locally. If you have the minimum r, that's going to be the closest distance locally. Now, in order to do linear approximation in polar, you have to first know two things. One, you need to know the average rate of change on an interval. And 2, you need to know 1 point on the graph. So you can approximate values using point slope form. So in linear, we have y minus y1 is equal to mx minus x1. So here, this is going to be y is equal to mx minus theta 1 plus f of theta 1. So our m is going to be our average rate of change, which was m is equal to f theta 2 minus f theta 1 divided by theta 2 minus theta 1. So let's do a practice problem with this. Let's say that we have a point 6 pi over 4, and it is on the graph of r equals f of theta, and that is going to be 6 sine 2 theta. And we want to know r value when theta is equal to 0.789. So which interval would you use to approximate f 0.789 and y? So if we have our table of values, which is going to be, so this is our graph of r is equal to 6 sine of 2 of theta, where 0 is going to be less than or equal to theta, and that's going to be less than or equal to pi over 2. So here are our tables, and we're going to choose the interval of 0.785 to 0.795. That's because 0.789 is included in that interval. Now what we want to do is approximate f of 0.789. So you're going to use the slope on the table, and that is on the interval. So from 0.785, 0.795, and our 0.6 pi over 4, we can write our linear equation in point slope form, and that's going to look like y is equal to negative 0.0x minus 0.785, and then if you substitute in, you have r of 0.789, 0.110, 0.789 minus 0.046, negative 0.00044 plus 6, that's approximately 5.996. So what is the average rate of change? Again, so this is our approximation, but our average rate of change, it is going to be the rate are changes based in theta units. That's units of r over radians. Now, let's do some more practice problems. So, let's say that we have the point 4 pi over 3 on r is equal to f of theta, 4 cosine of theta, and then we have the average rate of change of r on the interval of pi over 3 is less than or equal to theta is less than pi over 3 plus 0.02. And that is going to be -2. We want to approximate f pi over 3 plus 0.01. And you have to use point slope form. If you want, you can pause the video and try this yourself. I'm gonna put this over here. So for our first question, we have our point slope form that we want to get, and we also have the interval. So we have our average rate of change is going to be on and that is our m. So we can write first the point slope linear approximation. Our x is going to be our input. So y is equal to mx minus theta 1 plus f theta 1. So here m is equal to -2. Theta 1 is going to be equal to pi over 3. And our f theta of 1, actually theta 1, and here this is going to be our f theta 1. So we can substitute in y is equal to -2 x minus pi over 3 plus 4. That is this entire piece here, and our pi over 3 is here, and we have our m right there. So if you substitute in x is equal to pi over 3 plus 0.01, you have in parentheses f pi over 3 plus 0.01 is approximately -2 parentheses of pi over 3 plus 0.01 minus pi over 3 plus 4. So inside of your parentheses, that's 0.01. So you can write this as -2, 0.01 plus 4. .98 is going to be your approximation. Now, let's say that if we have a point 5 pi over 6 and f pi over 6 is equal to 5, and our average rate of change is 5 pi over 6. This is going to be 5 sine of theta. Instead we have pi over 6 plus 0.04, and this is going to be equal to 3. and we want to approximate pi over 6 plus 0.02. So how you do this is similarly we can write this as pi over 6 plus 0.04, and we want to find this. We start with our point slope linear approximation. Y is equal to 3x minus pi over 6 plus 5. Now you can substitute in x is equal to pi over 6 plus 0.02. And remember that y is equal to f of x. So we can write this as f pi over 6 plus 0.02 is approximately going to equal to this inside of our parentheses. This is just going to be 0.02. So overall, this is 5.06. Now, let's say in one last problem, that we have three pi over 2 on the graph of 3 minus cosine of theta from the interval of pi over 2 plus 0.02. This is going to equal to -1, and we have pi over 2, 0.01. We want to approximate this. Now we're going to do the same thing. This is pi over, we have, that's how we got our 3. So pi over 2 plus 0.02. We want to find this. So we start with our point slope linear approximation. Now we can sub x is equal to pi over 2 plus 0.01. This is 0.01. So 2.99 is your approximation. The polar function is r is equal to f of theta. Focus is near theta is equal to pi over 6. The following table gives the average rate of change. It is known that f of pi over 6 is equal to 4. Is there a relative max or min near theta is equal to pi over 6? Explain why, and state the coordinate of extremum. So first we have to identify the sign change. So before we go from 0.5 to 0.54, we can see that the average rate of change is positive. Therefore, R is increasing. Now we see that the average rate of change is negative, so R is decreasing. So it goes from positive to negative. Positive to negatives means you have a local max. So where does this happen? The sign flips between the interval 0.52 to 0.54 to 0 and 0.54 to 0.56. So that means that the is near the boundary. Our boundary is 0.54, so we can say that it's approximately 0.54. We're focusing on the area that is near theta equals to pi over 6, and pi over 6 is 0.524, which is right in that neighborhood. So near pi over 6 is consistent. So so the coordinate of extremum we know that f pi over 6 is equal to 4. So the coordinate using the known angle and value, we can write 4 pi over 6 for this first question. So this was a local max. Now for our next question, focus near pi over 6. So we have our intervals. First, we want to identify sign changing. So it's negative, R decreasing, R increasing. So here we're going from negative to positive. That means you have a local min. So because it flips here, that means that theta is approximately 1.06, which is our boundary. Where does that happen? So we know that pi over 3 is approximately 1.047, which is right here basically. So we know that 5 pi over 3, given this as our coordinate. So we can write our full coordinate now as 2 pi over 3 as our. Here we have positive, and here Oh, 2 pi over 3. Yes. Okay, here we have positive, and here we have 0, and then negative. So this is flattening, no change over this interval, increasing, decreasing. So it's positive, 0, negative. This is the same as positive straight to negative, which is going to be a local max. The change occurs from 0.78 to 0.80. That means we can say that the turning point is probably going to be 0.79 at the middle. And we know that pi over 4 is approximately 0.785. So that means it's basically matching this. So f pi over 4 is equal to 6. you can write 6 pi over 4.